Hello everyone, and thank you for the opportunity to be here at the BIM Summit 2024. My name is Yaniv Hatiel, and today I will be presenting on rethinking BIM workflows, leveraging Rhino inside Revit. In this presentation, we will explore how the workflow we developed can enhance design flexibility, responsiveness, and collaboration in architectural projects. I've worked on several significant projects, such as leading the Oriente Green Campus as a project BIM specialist, designing the facade for Eden Foundation high-rise learning center, and developing a data-driven facade for Yandex headquarters. First, let's understand the strength of Rhino and Revit. Rhino is a versatile modeling tool that allows us for quickly exploring and iterate, making it ideal for the early stages of design. It excels at handling complex, free-form geometries and giving us the flexibility to experiment with different ideas. Revit, in the other hand, excels at generating comprehensive documentation, including detailed construction drawings, schedules, and specification, ensuring that all aspects of the project are truly covered. This makes coordinations across different disciplines seamless, ensuring that architects, engineers, and constructors are all working with the same up-to-date information. Let's take a closer look at the recent project by Zero One Architecture, the Wind Sail Tower. The project demanded a balance of aesthetics, functionality, and precision, requiring us to push the boundaries of design and coordination. In the early stages, we leveraged Rhino to explore different massing options, focusing on refining the building's overall geometry. By using sub-D modeling tool in Rhino, we were able to experiment with different forms and quickly iterate on the design. Additionally, we automate the creation of architectural elements, which ensure that the design details were consistent across the building. Buildings are complex systems with a vast amount of information that grows as the project develops. In the initial design stage, we aim to keep the model responsive and focus on the relevant information that help us to study the visual impact of our design decision. This is where the concept of LOD, level of development, becomes essential. By effectively managing LOD at each stage, we streamline our workflow and ensure that the model evolves with the project needs. LOD 100 represents the building's basics form and massing. This level is typically used by early stages to explore different massing options and concepts. It helps architects and planners to visualize the overall layout, the scale, and the relationship of the space. All floors and levels are automatically generated in Revit based on the geometry created in Rhino. This seamless integration between Rhino and Revit allows us to transition smoothly from the conceptual design phase in Rhino to the detailed development phase in Revit, without needing to rework or recreate elements. What makes this workflow so powerful is that once the geometry is brought into Revit, all the elements, whatever its floor, walls, or structural components, become native Revit components. This means they are fully editable and can be adjusted, scheduled, and documented within the Revit environment. By ensuring that all elements are native Revit components, we're maintaining a full control over the project as it evolves, allowing for flexibility and precision in the later design stages and constructions. Once we have a solid understanding of the general massing, we move on to the next crucial step, exploring the facade. We indicate each color to each facade system. A well-designed facade has to achieve several objectives. It must perform well in terms of energy efficiency, providing a positive interior experience, and contribute to the overall building appearance. As we develop these facade concepts, any changes made at LOD 100 are automatically applied and carried through to the advanced design stages. This process enriched the 3D model with intricate facade elements like mullions, panels, transom, etc. Additionally, any changes made to the massing are immediately reflected in the facade, allowing us to focus on design tasks and make adjustments as we go. This real-time update capability ensures that we can keep iterating and refining the design while staying aligned to the overall vision. By embedding these parameters directly into the panels, we ensure that all relevant data is transferred to Revit, where it can be used for project management, coordination, and scheduling. This integration allows us to retain full control over the facade rationalization process within Rhino, including the ability to run sorting algorithm and flatten curved panel as needed. This is especially important in complex projects where we need to maintain both design flexibility and precision. Ultimately, by translating the facade components from Rhino to Revit, effectively we can continue refining the design in Rhino while ensuring that all components remain fully editable and manageable in Revit. This streamlines approach bridges the gap between the creative design phase and the technical requirements for construction, enabling us to deliver a more accurate and well-coordinated project. In conclusion, the integration of Rhino and Revit through Rhino inside Revit represents a significant advance in how we manage architectural workflows. By leveraging the strength of both platforms, we can achieve greater flexibility, responsiveness, and precision in our projects. Managing level of development within the integrated workflow ensures that relevant information is accessible and manageable at each stage of the project. As architecture continues to evolve, adopting integrated workflow like Rhino inside Revit will become increasingly important for delivering high-quality design that exceed client expectations. Thank you for your attention and looking forward to see you in person in Dublin.